All right, this is day 2 of probability. Like I said in the past video, we're not just doing sections. I'm just going to kind of talk for a few minutes until I run out of time and then resume wherever I left off. So this, technically from the book, this is the middle of, or the second half of 6.2. Okay, so this is a two-way table. I took this question straight off of the 2011 AP exam. And the reason we did two-way tables at the beginning of this unit is because a lot of probability questions are based on a two-way table. I want to talk about 3 styles of questions that can come from a two-way table. All right, an and, an or, and a given. They're just basic questions like, you know, one of these people is chosen at random. What's the probability that they were a male? Well, we would take 200 and put it out of 500 and get 0.4 or 2/5 or 40%. We start to do a little bit more complicated questions involving the words and, or, and given. So let's talk about and first. In math, and does not mean add up all the males and add up all the people who are in party X. In math, and means you have to be both. So the probability that a randomly chosen person was a male and they were from party X. So here are the males. There's 200 of them, some from each of the political parties. Here are the members of Party X. So who was a male and a member of Party X? Well, the overlap of those two groups, the 124 people who were both out of 500. And then I could simplify that. Let me show you a little calculator trick if you don't know about it. Let me get out of here. So we had 124 out of 500. Math enter is a good trick, and we're going to use it a lot in this probability unit. Just hit math after you've calculated the decimal. Enter on turn to fraction. Enter one more time. And 31 1/25 is the simplified fraction version of that answer. And you should know, and we'll talk about this in just a minute, but a probability can be a fraction, a decimal, or a percent. They all mean the same thing, and it just depends on the context of the question. Okay, so that's and. You have to be both to be in the and category. So let's talk about or. Or questions mean you could be either or. Okay, we have female or Y. So here are the females. Here are the members of Party Y. So generally speaking, or means add. We need to add up the 168 females and the 300 females and the 168 members of Party Y. However, those two groups overlap. All right, so I need to give you a definition. So we'll just kind of skip down a minute, and I'll put a definition, and you can put this wherever in your notes. Disjoint doesn't mean let's go smoke disjoint. Disjoint means no overlap. Another word for disjoint is mutually exclusive. All right, the opposite of that would be joint, or there is an overlap, or not mutually exclusive. All right, so it matters if your events are joint or disjoint when you're doing an or question. All right, female or Y. We cannot just add those together. If I said, what's the probability that they were in Party W or Party Y, I could just add the 88 right here to the 168 right here, because there's no overlap between W and Y. So I don't have to worry about the fact that people are getting double counted. If you do female or Y, there is an overlap because there are females in Party Y. So there's a couple ways to approach it. I can just add up the 4 numbers that I have highlighted, the 60, the 120, the 120, and the 48. Technically speaking, what I'm doing is I'm taking the probability of a female, which is 300 out of 500, and I'm adding to that the probability of party Y, which is 168 out of 500. And let me get rid of this little note that's coming later. And because these are joint events, meaning you can be both, I need to subtract the 120 out of 500 that got double counted. All right, all the females who are in party Y get to be a part of this group, but they don't get to be counted twice. They're just one person, even though they're a member of both of those groups. So let's see, that's 300 plus 168 minus 120, so plus 48. I believe that's 348 out of 500. And you can just simplify that on your own. All right, so or questions, it matters whether they are joint or disjoint events, whether or not there's any overlap in the groups. All right, so lastly on this little table, this is the actual question that was asked 2 years ago on the AP exam. Given a randomly selected voter is a male, what's the probability that he or she is registered party Y? The only time your denominator is not going to be 500 is if it's a given question. This is called conditional probability. Under the condition that we know we're talking about a male, what's the probability that they're in group Y? This little symbol, the note I just erased, this vertical line means given. So you can write Y given male or Y with a line and then male. The thing that comes after the line is the thing we know is true. So for this question, I know this person's a male. I know that I am only dealing with these 200 people. Now, assuming that's the case, what's the probability that they are in party Y? So I take 48, but I don't put it over 500, I put it over 200, which would be 24 over 100, or we'll just call it, do this one in percent, 24% or 0.24. So the only time, like I said, that your denominator will not be 500 is if it's given. Conditional basically just narrows down who you're talking about, and that kind of talks about, it connects to when we did conditional distribution in a two-way table. All right, so that's some examples of two-way tables straight off your test. We'll get to this independent one in just a minute, part B of that question. Let's do some probability rules. There are 4, and some of them seem very obvious, some of them might not, but here's the first one. They're going to be kind of abbreviated. All probabilities are between 0 and 1. 0 being impossible, 1 being certain, and everything in between. And like I said before, it could be a decimal, a percent, or a fraction. Rule number 2, all possible outcomes add up to 1. Again, that might seem obvious, but if you take the probability of every single way an experiment could go and put them all together, you get 1. The probability of rolling all the different combinations of 2 dice, they're all different, 7 being most likely, 2 and 12 least likely, but you add all those fractions together, you're going to get 1. Complements. Complement is just another word for kind of opposite. If there's an event A, it's A with a little C complement, and that means it did not happen. It's 1 minus the probability of A. Should put probability of A complement is 1 minus the probability of A. And this just means it didn't happen. You know, the weatherman says there's a 20% chance of rain today. We know there's an 80% chance of not rain today, and you usually just do that in your head. So that's called a complement. All right, and then rule 4 is about disjoint. A and B are disjoint or mutually exclusive if they have no outcomes in common. If that's the case, for disjoint events, then probability of the or, A or B, meaning either one of them can happen, is probability of A plus the probability of B. All right, so another very common example, or a common setup for problems is a deck of cards. All right, I draw 1 card from this deck. What's the probability that it's a 5 or an 8? Well, are 5 and 8 disjoint or joint? Well, 5 and 8 are disjoint because there's no cards that are both 5s and 8s. So each card, each individual value, ace through king, is a 1 out of 13 chance. That's 4 out of 52. So I would just have to add 1/13 and 1/13 to get 2/13. Okay, if I asked what's the probability of a 5 or a heart, well, that's different. All right, I can't just add up the 5s and the hearts. Okay, the 5s, there's 4 out of 52 cards. I'm going to do this out of 52 because I think I'm going to need that common denominator anyway. 4 out of the 52 cards are 5s. 13 out of the 52 cards are hearts. But because these are joint events, the 5s and the hearts, here are the 5s, blue and yellow make green. Here are the hearts. The 5 of hearts is the overlap. That's the one that won't let me just add them. So I need to subtract that overlap. All right, I counted it twice. I'm going to subtract it once because I want to include it. I just don't want to include it both. I need to include it as a 5 or a heart and not both. So it was 17 minus 1, 16 out of 52. And then I believe that's 4/13. So just cards are a perfect example. Whether or not you play cards, you'll probably get a lot of cards questions anytime you're dealing with probability because they just set up perfectly to ask these questions. So let's talk for a second about independence. And I probably have mentioned this in class, but independence basically means one thing doesn't affect the next. Two events are independent if whatever happens the first time doesn't affect what happens the second time. And this always comes up with card questions. I'm going to draw a card, and either I'm going to put it back before I draw it, or I'm not going to put it back before I draw the second one. So that's called replacement and non-replacement, which came up in section 1. So I'm not going to spend a whole lot of time talking about this, but just think about it in terms of the cards. You draw 2 cards. What's the probability that they're both aces? Well, did I put the first one back or not? If I did put it back, then it's 1/13 times 1/13. If I did not, it's 1/13 times 3 out of 51 because there are only 3 aces left and there are 51 cards left. So I want to talk about a different style of independence questions to finish this one up. To do that, let's look back at the AP question that we started with. Question B, among the registered voters, are the events male and registered for Y independent? All right, technically the definition of independence means this. The probability of A is the same as the probability of A given B. This is the mathematical version of the definition of independence. And if you just think about it, A and A given B should be the same. If it doesn't matter whether or not B happened, then A given B is just the same as it already was. Like, what's the probability that I flip tails given that I just flipped heads? Well, it's the same as if I just flipped tails anyway. That's independent. So if you have a two-way table and they ask you for independence, we need to check these 2 things. And what I got probably 75% of the time on this test question last year was, well, it doesn't have anything to do with whether you're male or female, what party. Just because you're a male doesn't mean you're going to have to be in party X. That's not the question. It's not whether there's an association between your gender and your party. It's mathematically speaking, to be independent, is A the same as A given B? So is male the same as male given Y? It's the probability that you're a male, the same as the probability that you're a male given you belong to party Y. So let's check those. The probability that you're a male is 200 out of 500. All right, we had 200 males and 300 females. So there's 200 out of 500 being male. Male given Y. Remember that given means I know that I'm a part of party Y. All right, so out of 168 people, what's the probability that you're a male? Well, 48 out of 168. So here's the deal. Almost never will these 2 fractions equal each other. If the proportions just happen to work out right, then it will. But let's check it. I know the one is 0.4. Let's do 48 out of 168. 48 out of 168 is 0.2857, which is not 0.4. Let's just call it 0.29. So the question is 0.4 the same as 0.29? Obviously not. All right, so these are not independent. These are dependent events. So the toughness on the test question is, I'm going to tell you that it's dependent. You're going to say, no, it doesn't matter. I mean, just because you're male doesn't mean you have to be in Y or you can't be in Y or whatever. But that's not the question. All right, I promise you I'm going to ask you this, and I promise you some people are going to try to explain to me how it doesn't matter what gender you are, you can still be in any party. But that's not what I'm asking you. I'm asking you, do these probabilities match up or don't they? So we're going to finish part 2 with that. And I'll be back shortly with probability part 3. See ya.